this is the summary so far. So how we started with the basic question that for a function whether you can give an algorithm to compute, and we reframed this question to a set membership problem of the set graph of f, which is a representation which is a natural set associated to every function. So every function can be associated to a set graph of f, and we reframed this question to this question, and we saw how the answer to this, whether you can give an algorithm to solve set membership problem, if it is yes, then it is yes for this also, if it is no, then it is no for this also. And then we saw how this graph of f is limited to set of finite strings, which is a language, and the entire discussion shifts to set membership of languages. And this is the core theme of TOC. The set membership of languages, set membership problem of languages is the core theme of TOC. Language can be finite or infinite, and in case of finite languages, we can have this conventional method to determine whether a string belongs to the language or not. But that conventional method will take a lot of time for infinite language. If the language is infinite, it will take a lot of time. So what we have to do is to come up with the finite representation of language. You have to come up with models of computation, and these models of computation are the finite representations of language. These models of computation are the finite representation of language. And using this model of computation, we will solve the set membership problem. We will solve the set membership problem mechanistically. And that is why it is called machines or automatas. Very good. Now, just as in the first slide, we saw that only tiny fraction of the functions will have an algorithm. In the first slide we saw that only a tiny fraction can have algorithms. Similarly, there will be many such languages for which you won't be able to give any model of computation, because there were many functions for which you have no algorithms. If for function you have no algorithm to compute, it simply makes sense that the graph of that function will have no algorithm to solve the set membership problem. So corresponding to those functions, the languages corresponding to those functions, there will be many such languages, and you won't be able to give any model of computation or automata for those languages. But there will be a class of functions, or there will be class of languages for which you can give different classes of automatas. Okay, and that's how we classify the languages. The languages are classified based on what type of automatas you can give for it to solve its set membership problem. For example, there are many different types of automatas. Let me take a new page. Languages are classified based on what class of automata you can give corresponding to that language to solve the set membership problem. So if there is a language L, and for this language, if you can give a finite automata, there are different types of finite automata, like for example DFA, NFA. We will see in the coming videos that how any finite automata, whether it be DFA or NFA or epsilon NFA, they all are equivalent in power. So if you can give a DFA for a language, for that language you can give an NFA. So we will actually see that how you can convert a NFA to DFA, because what is the equivalent DFA for a given NFA. Those things are coming. But right now, if for a language, if you can give a finite automata, then this language is of the category regular. If you can give a finite automata for a language, then that language is regular language. And similarly, if for a language you can give a push down automata, then this language is context free language. Context free language. So there are basically two things so far. Two things. Number one is that the languages are classified based on what type of automata is possible for this language. And number two, that the main purpose of these automatas is to solve set membership problem of the language. Set membership problem of the language. And for every automata, basically every automata is a finite representation of one language, and it is for this language that it solves the set membership problem. Mechanistically. Okay, and we will end it here.